Okay, let's continue on how to write the equation, the vector form of multiple variables. So vector form of multiple variables. And the first one, we're given this plane x negative 2y plus 3z equals 9. And we want to write the equation of a plane perpendicular to this. So if I want to write the equation perpendicular to this plane but passing through the origin, I need to first find the new direction vector. In other words, I have to find the direction vector going through the origin perpendicular to this plane. Well, because I know that this direction vector is 1, negative 2, 3, I can get that from my A, B, and C. I know that if I dot that with the new direction vector, that dot product has to become 0. So what we're looking for is the direction vector. So I just need to think. So I'm just going to make up some numbers. For example, I might make this a negative 1 and 1. And now I just have to find my z coordinate. So using the dot product, if I get negative 1 minus 2 plus 3 times something, that has to be 0. Well, of course, if I make this 1, that's going to become 0. So this is the direction vector now of our new vector that's going to be of our new plane perpendicular to this plane but going through the origin. So now I can write out my equation. I do have a point, 0, 0, 0, the origin, and I do have my direction vector, which is going to be this negative 1, 1, 1. Using our equation, to write the equation of a plane, you can look at an earlier video for this, x minus x naught plus b, y minus y naught, plus c, z minus z naught, has to equal 0. Ran out of room there. And plugging this in, you would get negative x. Those are just zeros. These are just all zeros here. This becomes plus b, which is 1, so plus y, plus z would equal 0, and that would be our equation. To write this in function form, we would say, of course, z is a function of x and y, and that's going to equal just x minus y. And that would be our function form for our plane. Now, the second question, we want to write the form for this elliptical parabola. Oops, I forgot to give it to you. So let's go ahead and write that out here. It'll be y squared over 9 plus z squared equal to x. To write this in function form, we just solve for z. So we would get z squared equals x minus y squared over 9. Therefore, z would equal plus or minus the square root of x minus y squared over 9. But again, we want to write that in function form, so we should use f of xy, and that's going to become plus or minus the square root of x minus y squared over 9. And there's our function form right there. Now, we now want to find the vector form for problems number 1. So for problem and 2. So for number 1, remember we were given f of x y equals x minus y. To write this in vector form, remember we would normally use t, but now in multiple variables we use u and v. So to write this in vector form, I'm going to go back to my original, which was just this. It was I guess I go negative x plus y plus z equal to 0. So I'm going to solve for z here. So I guess I could have z equals x minus y. And if I let x be u and y be v, remember I always put a hook on my u's there, I would recommend it, then I could say z then would equal u minus v. So my form r of u v would equal x, which is we said was u in the I direction, plus v in the j direction, plus, and z would be u minus v in the k direction. And that would be our form. I kind of ran out of room there, so I'll give myself a little bit of space there. So for problem number 2, I'm just going to keep this in z already. Z was plus or minus the square root of x minus y squared over 9. So right here, right away again, I could let u equal, or I guess I should say keep consistent. Let x be u, let y be v, and then z would be, what is that? Plus or minus the square root of x minus y squared over 9. So writing this in our form, we would get, let me go ahead and do this real quick. We're going to run out of room here, so I know that. So I don't need that much space for all of this. So we would get r of u and v would equal u in the x direction plus v in the, whoops, that's a weird looking I. There we go. That should be an I. Plus v in the j direction, the y direction. Plus or minus, it's okay to write it this way. The square root of u minus v squared over 9 k. And that would be our answer for that. Again, it's just like in pre-cal, right? When your teacher would say, okay, write this function y equals x squared as a parametric, you would say, okay, x would be t, y would be t squared. It's the same idea. Except for now we would have r of t would equal, what's that? T I plus t squared j. My eyes always look like j's. There we go. And that would be our equation for that. So it's the very same thing what you did in pre-cal, except for in multiple variables, we have two independent variables. That's why I thought u and v. All right, so let's say we're given the opposite, okay? So we're given this function right here, and we want to classify the quadratic, convert to function form, and then draw the contours. So this would be a good quiz or test question because it asks quite a bit. So to do this, we take a look at what we're letting it equal to. X in this case is just x, but what is y equal to? It's just x squared minus z squared. And z, of course, is just z. So to classify the quadratic, the easiest way to classify these is just look at the one with the most. See here, x and z are already themselves, but what is y in terms of? Y, this is basically saying y is in terms of x and z. So therefore, y is our function. X is already in terms by itself, and so is z already in terms by itself. But y is in terms of something else. So x and z are my independent variables, so y is my function. So if I want to classify it, I am looking at, can't spell, right? That should be a quadratic surface, and we want to identify what is y equal to x squared minus z squared, because this is what I'm looking for. Remember, y is a function of x and z, and of course this is our hyperbolic paraboloid. Right there. Convert to function form. Okay, well, I already got y, right? I already have y, so y this time is a function of x and z. So my function x and z would equal x squared minus y squared. Notice, it doesn't have to be function of x and y, it's whatever your independent variables are. These are your independent variables, and those are what your functions are in terms of. Next, we want to sketch the contour plots. Okay, we want to sketch the contour plots when y is 1, negative 1, 0, 1. So we did this before. So remember, f of x here is y, so if I let y equal negative 1, we plug it in, we get negative 1 equals x squared minus y squared. And simplifying this one, we don't like the way that's a negative 1, so we would get y, hold on here. There we go. We would get y squared minus x squared equals 1. And this is a hyperbola. If we let y equal 0, we would get 0 equals x squared minus y squared. And we talked about this when this becomes x equals plus or minus y. These are our two lines. And remember, we call this a degenerate hyperbola. It wants to be a hyperbola, but it's not going to become one. When y is 1, we would get 1 equals x squared minus y squared. Again, another hyperbola. And when y is 4, I keep on saying y, but these y's should be what? Z's. I can't believe I did that. Nobody told me that. These all should be z's. Z squared. z squared, sorry about that. When we let y is 4, we would get x squared, 4 equals x squared minus z squared. And again, another hyperbola. I'm sorry about that. All my y's should be z's. I get such a habit right now, x and y, which everybody does, but be careful with that, okay? All right, next we want to draw them. To draw these, we have x. We're only looking in z, not y. All right, so our first one is z squared minus x squared is 1. So that's going to be up on the z-axis and z-axis down here. And it's going to be our hyperbola. Next, we have our degenerate hyperbola. That's the line y equals x and the line y equals negative x. Next, we have the parabola, hyperbola, right here. X squared minus z squared. Let's make that look like a better looking z. Z squared. Right, we're right here. And that's going to equal 1. So now, be careful, x is first, so we're going to be the x coordinate. Right there. And then the last one is 4, but be careful when you draw this one. This is really x squared over 4 minus z squared over 4 equals 1. That's going to put me at 2 and negative 2. And on the x's first, it's going to be our hyperbola like this. Again, oh no, don't worry. I know I'm going to hear a lot of comments on that one. I forgot this should be x squared minus z squared. It should match. Remember, your independent variables here should match up on the right side. Sorry about that. But I hope you guys enjoyed the video and my error there, so I'll see you guys later. Bye-bye.